Good afternoon, everyone. The current progress on speech technologies and its future prospects. This is a casual session with panel discussion under this theme. My name is Dr. Togami. I will serve as a moderator for this session. And this is the overview of this casual session. In DevDay 2020, as we are reporting end-to-end speech processing technologies and the speech synthesis and the end-to-end processing techniques is a very hot topic. So that it has come to a stage where we can make use of those technologies. And also the environmental voice recognition technology, the new area is now expanding. So this area is becoming more and more interesting area. This is what I'm feeling. So speech processing techniques is the theme, and we have invited engineers and researchers who are playing a major role in this area. So these are the panelists, and we would like to show you the current progress on speech technologies. And in the technological side and application side, how is it going to evolve? So we would like to discuss the future prospects of these technologies as well. Now I would like to introduce to you our panelists. First of all, in our speech team, end-to-end speech recognition technology is led by Kida-san, Mr. Kida. Thank you very much. And the second speaker is from our voice team. The DNN-based speech synthesis technology is led by Yamamoto-san. And Yamamoto-san, please. Thank you very much. And the third speaker is a guest panelist. He's an expert in the expert sound recognition, Dr. Imoto of Doshisha University. Thank you for your participation. Thank you very much. Now we would like to have self-introduction from each panelist. And let me start with me. I'm from Line. I'm a manager of speech team in Line. My name is Togami. And the noise environment recognition level should be improved, and so I'm now engaged in a research of speech source separation. This is my publication, actually. I published a book titled Sound Source Separation with Python recently, so please read that book if you are interested in this theme. And now I would like to have self-introduction from each panelist, Kida-san, Yamamoto-san, and Dr. Imoto. And major topics should be presented by each panelist. And Kida-san, please. First, I'm from speech team of Line. My name is Kida. As you see here, Toshiba, Yahoo are my previous companies, and I joined Line in May this year. And from Toshiba era, I have been engaged in the speech recognition technology. And in Line, I'm a tech lead of product development of speech recognition technology. So this is a recent progress of speech recognition technologies. I show some examples. There are several. And the left top is accuracy. At this moment, in a quiet environment, if you speak close to the microphone, in such an ideal environment, the technology is quite accurate, as high as human. However, it's a heavy data. So only on the server, the speech recognition was possible. But now, in a later smartphone, the speech recognition is becoming possible to some extent. And on the right top, so this is a scene where many people speak at the same time. And the people can recognize the voice of the person that they would like to hear. But likewise, on computer, even if multiple people are speaking, it's now becoming possible to recognize the voice of the person that is interesting. Then in the research area, the meeting transcription by single microphone. That is becoming possible gradually. And so now there is an expansion of the application of speech recognition because of the end-to-end speech recognition. That is a new technology that is emerging. And on the left side, this is a conventional structure. So the acoustic model, language model, lexicon, these three modules were combined to recognize the speech. And on the other hand, in the end-to-end, on the right side, there is one neural network. So from speech to text, this framework can be applied. So end-to-end speech recognition has a simple structure, but it depends heavily on the neural networks so that the recognition level has improved very much. But for productization, there are many challenges to overcome. First of all, compared with the conventional recognition, response speed tends to slower, and also compute cost is high. The GPU need to be utilized. Otherwise, we cannot have a faster speed of recognition. And also, customization is difficult to identify specific words. So in order to productize end-to-end speech recognition, Line is very much active in research and development. Thank you very much. And next, Yamamoto-san, please. Thank you very much. I'm Yamamoto from Line. In 2018, I joined Line, and since then, I have been engaged in the R&D of speech synthesis. And in the main section, presentation was done, and the GPU, high-speed, high-quality text-to-speech, that's the main theme. Neural vocoder, end-to-end speech synthesis, the area where I'm engaged in my research. And what is possible in end-to-end synthesis? Very high-quality speech synthesis is now possible. And the Wavenet is a key for this. Wavenet is due to deep convolutional neural network is the basis, and one sample is created at a time. And this approach looks inefficient. However, this creates a very high-quality speech synthesis. And then specifically, how high is the quality? This is a result of the experiment. On the left, parametric, that is a conventional statistic speech recognition results. Before deep learning, machine learning quality of speech recognition was said to be bad, but thanks to the Wavenet, that situation has changed. Sequence to sequence machine learning is combined, then the quality has become higher. So this is very quite close to human level. And like in this way, the current speech synthesis technology is very much close to the human level. And then what are remaining challenges? There are many challenges to overcome still. For example, Wavenet, that has high quality. However, the speed is slow. So in our group, for productization, we are doing research. So lightweight, high efficient, high quality, that is a major topic for our research. And the news, not just news reading, but emotional speech or the controlling of emotion and speaking style, that is also another topic that we need to address. And low resource, that is another keyword. If there are a lot of data, the machine learning works. But if there are not so much data, what should we do? So how can we make use of little data? That is important, more important than before. For example, by recording several sentences in smartphone should make a clear voice of yourself. And that future is going to come from now on. That's all from my side. Thank you very much, Mr. Yamamoto. So now, Dr. Imoto, please. Thank you very much. My name is Imoto of Doshisha University, and my research is as follows. That's environmental sound analysis. machine learning and deep learning are utilized for analyzing environmental sound. That's my research. And also, in relation to that, microphone array processing is another interest, and not just analysis, but also by using machine learning, I also tried to make sound synthesis. Next slide, please. So this is environmental sound analysis. This is relatively new technology. So what is that? Maybe you might think so. So this is kind of the definition of environmental sound analysis.
So when we talk about sound analysis, environmental sound analysis, that's not just about the voice of human beings or music. So all those things, they are combined are the sounds, environmental sound. So the applications of environmental sound analysis is not that many. However, this is a technology that could be applied in various areas. For example, if there's a glass shattering sound is detected, then it could be used for surveillance purposes. Or if a baby is crying, then it could be used for home monitoring and autonomous driving. It could monitor animals, or it could automatically tag the video, automatic live logging. So there are various applications in the use of this environmental sound analysis technologies. So this is still a new technology, so therefore there are obviously very many challenges. There are two things that I have raised here. So machine learning or deep learning technology has the common problem. It has to collect so much amount of data. Especially for the environmental sound analysis, what's the issue here is that various sound will be could be heard in a layered various sound could be heard at the same time. So therefore, it's important to identify this sound has been heard from this time to that time. It's so hard to label those sound. So from where to where, the labeling of that is very weak. For example, this sound has a glass shattering sound. So we call this like a weak label. So through that, we try to identify the environment. So those are the research conducted recently. And also environmental sound does not include various information. So it's important to combine with different other information. For example, spatial information. Based on the microphone array processing, we try to use spatial information. If the glass shattering sound could be heard from the television or from the window, I think the meaning will be very different. So it needs to identify which, so that it can analyze the sound that needs to. So that sort of research is now being conducted very much recently. Thank you very much, Dr. Imoto, and also two gentlemen. Thank you very much for introducing yourselves as well. So various things are now becoming possible. I'm sure that the audience also must have felt that various things are becoming possible. So from here onwards, we'd like to ask the panelists to start discussing. So during which time, so from here onwards, I'd like to introduce several of the topics to discuss, and during which time, the audience participating in the session, please ask questions to the panelists. It could be individual question or to all the panelists if you could ask questions as well. However, we wouldn't be able to answer all your questions. Please bear that in mind. So there are 3 questions that I have prepared. So I'd like to go and ask the first topic. You've talked about various things right now, but in the progress of speech technology, the DNN progress is something that we could not ignore. And on the other hand, what other factors do you think are important in current speech technology, except for DNN? Because it's not just DNN, because there are difficulty for the speech analysis and speech processing and analysis as well. And together with that, I think DNN has advanced. So here, for those people who would be interested in speech processing, for those people who will be interested in the issues of the speech processing, and also the engineers who would like to know about what sort of technology are being developed in speech processing. I hope that we will be able to have more of those numbers of people who are interested. So to those people, if you could talk about what is the specific issue that DNN holds. So we'd like to ask the panelists, Dr. Imoto, what do you think in terms of environmental sound analysis? Yes, surely, in the environmental sound analysis has been developing together with DNN. It's a core technology. But as I have mentioned earlier, the environmental sound is so diverse, so many different types. So try to learn that with DNA. It will need so much massive amount of data. So with the current technology alone, that could not be realized. So it's important to know what one would like to do, and we need to have a domain knowledge or the pre-knowledge of what that could be used. For example, I'll talk about myself, but I try to identify in what situation the sound will be emitted. And in that, I'm thinking about using DNN. For example, even if you're outside, I could hear sound of someone using the knife in the kitchen. So that shan't happen. So even with the limited amount of data, it's important to identify, where the environment is. The scene and event to look at it regressively. So that is using the knowledge that the adult human has. Exactly. Kida-san, in terms of sound recognition, voice recognition, what do you think? Yes, as Dr. Imoto mentioned, domain is very important for speech recognition. Even if we have conversation, how we speak in the workplace and how we speak at home is very different, and how we process each of the words will be different. If you try to let machines do the same thing, it's very hard. So even using the current DNN, for a specific domain, it may be very strong. However, in other domains, it may be weak. So the versatile thing, using something versatile is very hard. So how to be able to give the specific data to improve is an important factor. So how to select the data, in other words? Exactly. So that is the key. Yes. So now I would like to move on to the next topic. So with that perspective, there is various technical challenges and technical issues. So ESA and also speech recognition and synthesis. So I'd like to ask this question to the three of you. In each of those areas, what are the cross-sectional areas in these technologies? For example, maybe the speech recognition technology could be applied to environmental sound analysis, but maybe it doesn't go well so smoothly. So what is the commonalities or the differences, or what one needs to think about, and the factors that we need to think about in the intersectional technologies? So from the speech synthesis perspective, Yamamoto-san, what do you think? Yes. In terms of speech synthesis and speech recognition is very much related. So speech recognition model could be used for speech synthesis a lot of the times. However, the biggest difference is the speech recognition recently in several thousand hours of learning data have been used. A massive amount of learning data will be used. However, for speech synthesis, it will require smaller data. For example, in the end-to-end, a smaller amount of data compared to the speech recognition. So there are differences as such. So we will have to think about this separately and individually. So maybe in the speech recognition, some of the areas are very successful, but perhaps we will need to identify, how we could do with the small amount of data that we have or speech synthesis. So speech recognition uses a massive amount of data and how to be able to respond to various speaking styles, etc. So, however, for speech synthesis, it's really about using the small amount of data and try to identify identify exactly. That happens a lot. So Kida-san, from the speech recognition perspective, is there any point that you would like to add? Yes, speech recognition and speech synthesis a lot of alignment and a lot of relationship with the speech synthesis. For example, in the end, using the speech recognition data, using the speech which it synthesizes, used for learning purposes. So various try to let the machine learn those terminologies. It will be hard to have human beings read it out loud. That would be too hard. So we ask the speech synthesis data. However, if it's just about a simple giving the data to speech synthesis and let the machine learn, that's not the case.
In the synthesis, small data is utilized, so the voice of the certain person is gathered, and that person's voice can be created. However, in the recognition side, it's necessary to recognize voices of many people. So it needs to provide the training data of different voices of different people. In that sense, it may be difficult to bring synthesis technologies to recognition area. But in order to solve that, from synthesis, not making waveforms, but the encoder part, the feature amount can be used. Such a direct approach should be possible. So that might be a possible area for bringing technology in synthesis into the recognition side. Thank you very much. Now I would like to pick up a question from the audience. This is for Yamamoto-san. So Yamamoto-san, please add your comment. For synthesis, the small data is utilized that was mentioned earlier. So why you don't use large volume of data? Please give a brief comment. And first of all, maybe I might cause a misunderstanding. Of course, a large volume of data can be used in some cases, but relatively small amount of data is utilized because for synthesis, the clear data recorded in a studio is necessary, so annotation need to be applied to the data in some cases. So studio grade voice, a lot of preparation of such clear data is difficult. That's why we use small amount of data. Thank you very much. In questions from the audience, there is related topics to the next topic. So let's move on to the next topic. That's the last one from myself. This is one of the topics for this casual session. What do you think about future speech processing technologies from now on? What is your prospect? Rather than prediction, but what would you like to develop is also okay. In the near future, maybe in 1 or 2 years, visibility is relatively good. So let's talk about the 10-year prospect. We would like to have a comment from each panelist. And also there is a question related to this topic. With DNN, technology has developed very much, and that is already understood. And what is the limitation of DNN? That's the question. Maybe you have seen the limitation of DNN. So please include the answer to this question into your comment. So Dr. Imoto first, please. So the first comment might be different from the question. And 10 years ago, the environmental sound recognition, that was the extraction of information from many different sounds. So not people's speaking. We put microphone to extract sounds from anywhere. Smartphone is now what people is carrying. So there are microphone all around in the home. So that once we can recognize sound information from many different places, then that information can be useful However, you might have a scare. You might feel scary, but we can take sound as we like. However, filtering should be applied to get sound that we need. So we understand what is happening in sound area. Then we do filtering of sounds. So in 10 years, probably in all microphones or most microphones, such environmental sound analysis technology should be included. That is our goal. With DNN, maybe lightweight is necessary. So the technology on the edge is going to be necessary. So this is the area where we need to solve issues. So on running DNN in cloud has a limitation. Do you think so? You're right. And then privacy aware is also important. In order to protect privacy, the environmental sound recognition is necessary. That's your point, I think. Thank you very much. So next, Mr. Kida. The language recognition, if you can touch upon that, that would be good. So around the world, there are many different languages. So maybe from now on, it should be possible to recognize languages. But some languages are similar, but is it possible to recognize or distinguish such similar languages? Maybe it's difficult to answer, but please make a comment, including the answers to those questions. So first of all, about the outlook of this technology, I'm not sure 10 years is sufficient or not, but now speech recognition is possible. However, it's still superficial in a sense. So the wave form is translated into text. That is what we do now. And the DNN also has a limitation. So that the communication between machine and human, the concept of the words should be understood as well. Otherwise, not reasonable answer comes back to a question. However, that is difficult to realize. We need to have very much breakthrough or innovation to realize this vision. But a model of deep learning has breakthroughs every 1 or 2 years. And from before, I think that speech recognition is going to have a limit without understanding the concept of the words. And this trend, is it going to continue, or are we going to have a limitation in several years? So that we need to address the technologies to understand the concept of the words. So the turning point is likely to come. The language recognition, that was the question. And now it is becoming possible to some extent. And I would like to show you some interesting story in relation to that topic. English, Japanese. So now we are making a speech recognition device for each language, but the universal speech recognition device is another approach to recognize multiple languages. So as a training data, Japanese, English, and German, these are added, and the local minor language training data should be added as well to make a very large model. So in that case, the minor language training data is small normally, but there are a lot of corpuses in other languages, so that it can be added or complemented to a minor language. That is a kind of research that is ongoing. And that is the interesting topic that I would like to talk about. Thank you very much. So the speaking pattern are limited. So regardless of languages, such pattern can be utilized to some extent. Right, and thank you very much. So Yamamoto-san, please. The individualization of voices, I hope that that is going to develop further. And there are a lot of researches in this area. With a small amount of data, voice of a person, the reproduction of the voice is difficult. So the voice recorded in a smartphone, from that voice, a clear voice synthesis should be done, but that is a separate story. So the easy making of high-quality voice based on a small amount of data, that is the vision that I would like. I hope that is realized in 10 years. And also, as I mentioned in my self-introduction, not just reading of text, the voice should be emotional in some cases. And in 10 years, I hope that that technology to make emotional voice is going to be realized. Unfortunately, some people have lost their voices. So as a service for those people, I think that the technology is very important. Thank you very much. So now we would like to answer questions from the audience, although we have already answered some. And earlier, in the beginning, we received this question that is very interesting. So I would like to pick up once again.
So exactly for those students who would like to start studying about speech or voice, for those, if you will be able to tell us, what did trigger you to decide to conduct research on speech or voice? Maybe Dr. Imoto, if you could let us know. What's the reason you started this research? Well, I don't have any deep episode of why I've selected this topic, but I love music, so I wanted to be close to sound. So when I tried to select which departments to start, I selected a place where I will be able to do research on sound. So then that led to this job right now. So exactly close to what Dr. Imoto said, I originally loved music, and my mother was a piano teacher, and I was told that the music is mathematics. But I was playing baseball, in fact. But it just happens that I joined computer university doing computer science, and I got to know that we can research on music with this computer science, and from there I started to think that music is very interesting. The sound engineers, many people are used to play instruments or have played in a band. What about you, Kida-san? Yes, I was playing in a band as well, but nothing to do with that. Well, do you remember a movie called Minority Report? And I saw Tom Hanks doing a speech recognition. He's got a massive system at home, and he say, turn the light on, and then it was really cool to see all those things at home working, and that seemed like a magic. It was very futuristic. So I thought that it would be so cool if I could realize speech recognition, sound recognition. Yeah, Minority Report has really influenced the AI development, and I guess that is also the realization, isn't it? The speech recognition, it's exactly as you say. So I need to also answer that question. Well, originally, I was interested in universe, the cosmos. However, robot. I thought that if robot could hear people speaking, that would be great. And from there, I wanted to start researching on speech recognition. And I heard about Shotoku Taishi, a sage was able to hear 10 people's voice all at one time, and being able to recognize multiple people's voice all at the same time. And that would be very hard for a human being to do. However, if that could be realized, I thought that would be wonderful. So that's what got me to this research. Okay, so I think we will be able to answer to several other questions with the limited time that we have. This is a technical question. right now, you talked about speech recognition, and I'm sure that to some extent this has been done, but the context of the sentence or what's been said before and after, and to what extent is the context of the sentence being recognized in the speech recognition technology? What do you think, Kida-san? Yes, as I said earlier, I guess this also relates to the topic of domain. Technically speaking, I guess there are two. Short-term, in a short sentence to identify the context could be done with the end-to-end speech recognition. And the other is in a longer context, the language domain or those needs to be considered separately. So that will be covered on the language model, etc. But taking also the local area and also looks at the context as well. So I guess that's going to be the challenge. So those domain area or more abstract area, it's hard to put that in word, but those things will be taken into consideration in the coming future. Is that right? Yes. So I'd like to ask Dr. Imoto. So I guess this is also a technical question in environmental sound analysis. So to identify the orientation of where the sound has come from, that must be a topic in the DCASE as well. So perhaps that is still difficult right now. How is it right now? Yes. There's one thing it's hard for me to talk about. It's because in order to evaluate that, there's not enough data in this world. So to what extent of progress have we made is so hard to evaluate, to be honest. Well, technically speaking, as Dr. Togami said, to separate the source of the sound or to identify where the sound has come from, there's still, combination with existing technology, and this is in areas in which we need to develop and progress furthermore. However, in terms of possibility, the direction of the sound come from to that itself is becoming a task. So try to predict and identify where the direction of the sound itself is becoming a technology. However, if it's a ESA, environmental sound analysis, it's more like, oh, this sound comes from that side. That is where the kitchen is. Therefore, there's a dish clicking sound. So that kind of spatial analysis technology could be combined. So those are the areas in which we have not yet been able to work around as yet, and the technology that we think that we can make use of. I don't know whether I have been able to answer your question sufficiently enough. However, I think we're coming to an end. But so I'd like to make this last question. This is a speech synthesis question. In order to realize the emotional, expressional speech synthesis, what are the challenges or issues that you have? Yamamoto-san? Yeah, that's a very, very difficult question. I was thinking about this, in fact. Well, technically speaking, we have to think about what is emotion in the first place. We have to question that first of all. I think we can create a various variation sound synthesis. However, whether that is in line with the emotion, it's hard to know. So specifically, technically speaking, what kind of sound we can apply is also difficult to identify. And the emotional database is not enough, very little. So I guess that is hindering the progress of this technology. I guess the time is coming to an end, so maybe I'll stop speaking here. Yeah, the rest of the questions, we would like to answer them separately later on. Thank you so much for giving us all these questions. And this is just to let you know, the engineers, researchers, and students, we've also got this Tokyo Beat Bash that you will be able to participate. So please join this Tokyo Beat Bash. So I know that time flies, but the members of the panelists, thank you so much for joining today. And Dr. Imoto and Kida-san and Yamamoto-san, thank you. And also the audiences, thank you so much. So if you could look forward to how the voice technology will evolve in the coming future. So I guess we can wave to the audience and say goodbye. Goodbye.